In this problem, we're going to try to find the distance between A and B, two moving objects on these two parallel lines, y equals A and y equals B. We will have to find this minimum distance here, okay? And our intuition tells us that the distance is should be equal to this minimum distance between these two lines, okay? This line that has equation y equals A and this one that has this equation y equals B. But to do that, we need to do some work. We need to use some algebra or some pre-calc at least. We'll have to do some graphing, hand graphing of functions to find the solution. Okay, so the key idea is use the distance formula and try to find the minimum distance. Okay, so as these two guys, they move here, so we want to make this distance here minimum. Okay, as we see, if they keep moving, this one to the right and this one to the left, the distance will be big, and at a certain moment it will be infinite. And if they can get closer and closer to each other, there is a moment when they will be at this minimum distance here. Okay, we won't let this problem depend on time. Okay, we just want to find the position. Okay, that would help us find the minimum distance. We can also parameterize this problem by time and find the time when these two guys are close to each other. Okay, that's a different problem. But here we want to find the distance. Okay, and for me the distance is, as you can see, is when these two guys, they get close to each other. And in fact, when they are at the same line that's perpendicular to these parallel line, these two parallel line. So if one is here, the other one is here, this is the minimum distance. Okay, to find that and to see how we get it, we need to do some algebra at least. Okay, so to do that, we're gonna introduce a system of reference. Okay, we're gonna call this one X, O, Y. So O here is the origin, okay, the point that has 0, 0 coordinates. And this red line is the x-axis, and this one dotted red line is the y-axis. Okay, here we know the coordinate of A, at least the y-coordinate. Okay, so for A we know the y-coordinate, okay, which is A. The same thing for B. For B, we know the y-coordinate, which is B. So here we need to find the x-coordinate. Let's call the x-coordinate for A x. So this is my x here. Okay, and let's call the x-coordinate for B x prime. Okay, now the distance formula, we know the distance formula D, that gives us the distance between A and B, and B is so it's gonna be x minus, let me call this one x prime, so x minus x prime squared plus A minus B squared. Okay, we want to graph this function and see where the distance is minimum, but here we have two variables, x and x prime. We want to make this one a function of x. Okay, how to do that? To do that, we will have to get rid of the x prime, because we are used to functions in terms of x, okay, for one variable. To do that, we need to get rid of x. How can we do that? So basically what we're going to do, we're going to use similar triangles. As we see here, I'm going to use this triangle here, this small shaded triangle, and this a little bit bigger shaded triangle. Okay, so here I have these two triangles are similar. Why? because I have this angle here. I'm gonna call it alpha. It's vertical. This angle is alpha, the same. And this is a 90 degrees angle. This one is a 90 degrees angle. Okay, these two triangles are therefore similar. Okay, I can use the properties of similar triangles, but I can use something else. I can compute the tangent. Let's compute the tangent of alpha both ways. So tangent alpha in this small shaded triangle is gonna be this side here over this one here, which is a over x. For the bigger triangle, it's gonna be b over x prime. Since the tangent is the same, I have two quantities. The two quantities the same. So here I have a over x is b over x prime. Now I need to express x prime. X prime is gonna be, let's say it's b over ax. So this is the simplest way. So we can write it in this way. This is the simplest way that we can write it. Okay, so I'm gonna plug it here. Okay, so I have x minus x prime, which is b over ax squared, plus b minus a, or a minus b, doesn't matter because it's the square gets rid of the minus. Here I need to simplify this one more time, so I can take the x squared outside, and I have 1 minus b over a squared plus a minus b squared. I can do one more simplification here. I can take the a outside. I can write x over a squared plus times a minus b squared plus a minus b squared. I hope that you see how I get this one. It's just some factoring. Okay, I took the a outside of the square, and I have to divide, I multiply by here, by a. So therefore, I can take the a minus b, and let's have the absolute value here. And I have x over a squared plus 1. So this is my function. This is f of x. Let me write one more time. Absolute value of a minus b times x over a squared plus 1. So this is my f of x. So this is the function that's giving me the distance between a and b. Okay, and I see that it's a function of x. That's great because it's a function of x. Okay, and I want to find the minimum. Which x is gonna give me the minimum here? So here I can graph this function here. Okay, so this function is even. Okay, this function, I'm not worried about a minus b. Okay, let's forget about a minus b, and let's focus only on this function, square root of x over a squared plus 1. This function is 1 when x is 0, and it's even, it's symmetric like this. Okay, so this is my x-axis, this is my y-axis, and this point 0, here I have 1. Okay, so therefore I see that this function, because this is a constant, I don't worry about it. So here this function is f has a minimum when x is 0, and when x is 0, I'm gonna obtain the square root of 1, which is 1, times the absolute value of a minus b. Okay, and what does this one say? Look at this insect. Oh, this one is saying that when x is 0, that means a is here and b is here. So it's telling me that the distance is here. Okay, the minimum distance. Okay, it's this one here. This is b minus a. Okay, it doesn't matter which one is bigger, which one is small, which one is positive or negative. So the distance between these two is the absolute value is b minus a. So I have found that the distance using this system of coordinates is minimum when x is 0, and this distance is b minus a. And this happens when these two are on this line that's perpendicular to the 2. Okay? So here, this is the minimum distance, and it's b minus a, and it's intuitive. Okay, so the distance is minimal. Is minimum when the two guys are on the same perpendicular line. Okay. So here, but here it's giving me the minimum distance. Okay, so it's b minus a, and that's what we know. So here, if these two guys, they keep moving, they are at the minimum distance when this distance is b minus a. Okay, we will see that that this is the only minimum distance. There is no other minimum distance. Okay, so the distance b minus a is the minimum distance. Therefore, d minimum is b minus a in absolute value. Okay, this solves our problem here. And if you see any errors or any mistakes, please let me know, and please share, like, and subscribe. Thank you.